हेलो एवरीवन, वेलकम टू माय न्यू वीडियो ऑफ स्पार्क। आज के वीडियो में हम लोग डिस्कस करने वाले हैं हाउ टू रीड ए फाइल इन स्पार्क। स्पार्क सिस्टम में आप फाइल कैसे रीड कर सकते हैं, स्कीमा एक्सटर्नल रूप से कैसे डिफाइन कर सकते हैं और इंटरनली इन्फर स्कीमा कैसे कर सकते हैं। लेकिन आगे बढ़ने से पहले ये समझते हैं कि व्हाट इज सोर्स एंड सिंक। जैसे आप किसी भी डाटा पाइपलाइन के सिस्टम में काम करते हो तो देर इज सम सोर्स, वो सोर्स जहाँ से डाटा आती है, एंड देर इज अ सिंक वेयर यू डंप योर डाटा, वेयर यू फाइनली स्टोर योर डाटा। अब सोर्स फॉर एग्जांपल आपके ओरेकल हो सकते हैं सोर्स, फॉर एग्जांपल आपके टेराडाटा सिस्टम हो सकता है सोर्स, या सीएसवी फाइल से अगर डाटा आ रहा है, या सम काइंड ऑफ फाइल्स फ्रॉम द मेन फ्रेम सिस्टम। तो किसी भी तरह का सोर्स हो सकता है जो डाटा प्रोड्यूस कर रहा है, जो डाटा प्रोड्यूस कर रहा है आपके लिए स्पार्क प्रोसेसिंग के लिए। तो स्पार्क उस डाटा को दो तरीके से हैंडल करता है। अगर आपके पास लेस अमाउंट ऑफ डाटा है, साइज डाटा का जो वॉल्यूम है वो कम है, नंबर ऑफ रिकॉर्ड्स कम है, then with the help of Spark, you can directly connect with your source. You can use the JDBT connector, you can use the Informatica का अपना connector होता है, you can use directly Snowflake connector. So अपने अपने different tools के अलग अलग connector हैं, लेकिन you can use JDBC connector to connect to any external source. तो उस केस में Spark can connect to that external source. For an example, मैं लेता हूँ Oracle system as an external source. So Spark will connect Oracle with a JDBC connector एंड देन क्रिएट अ डाटा फ्रेम। तो आपको अगर किसी डाटा में फॉर एग्जांपल ओरेकल या टेराडाटा सिस्टम में डाटा है, उस पर स्पार्क प्रोसेसिंग करनी है, तो यू कैन नॉट यूज द कंप्यूट इंजन ऑफ द एक्सटर्नल सोर्स। कहने का मतलब आप ओरेकल और टेराडाटा के कंप्यूट इंजन को यूज नहीं कर सकते हो। यू हैव टू क्रिएट ए डाटा फ्रेम आउट ऑफ इट। यू हैव टू क्रिएट ए डाटा फ्रेम ऑफ द डाटा which is present in Oracle or in Teradata, whichever is the external source. So for creating the data frame, you need to have a connector. So for example, for the Oracle, I am using JDBC connector. With the help of JDBC connector, you will connect to Oracle, you will get the data, create a data frame, for example, source DF. And in that DF, you can do the processing. This is one way, but in most of the production scenario or in a bigger project, this way is not useful and this way is not used. So what ways we actually use in our project scenario is, we take the data from the source, we put it into some of the storage. For example, I am going to run the Spark on EMR. So I have the ecosystem of AWS. So in that case, what I will do, I'll just pull the data from one of the source. For example, Oracle is one of the source. I'll pull the data from the Oracle source and put it into some S3 bucket, my raw layer. And from there, we'll pull the data with the help of Spark and do the processing. So that means I'm trying to create some modularity between the source and the compute layer. So Spark is not meant for data ingestion. So in the first scenario which I had mentioned, that you can create a data frame by reading the external source data. So that way is possible in Spark, but Spark is not meant for that way, because in that way we are trying to ingest the file into our Spark system. So for ingesting the file, you have to use some integration tool, you have to use some Informatica tool, you have to use some AWS connector also, you can use Scoop also, you can use multiple tools. NiFi you can use to bring the data from the source to some of the storage, and from that storage, the Spark will do the processing. And finally, sink is the place where you write the output. The sink can be again the external database, Snowflake, Oracle, normal CSV, anything, or in the S3 bucket itself. So this is the source and the sink, and we have understood two ways how we can pull the data from the source. First, by creating a direct data frame for a small set of data, but in a bigger project and a bigger company, or the large source of data, in that case, you ingest the data from the source to some of the storage, and from that storage, you create a Spark data frame and do the computation and do the transformation and what all business stuff you have to apply. So now further we want to understand how we read a file in a Spark. There are multiple file formats, and Spark supports almost all the file format. And in my career, I have seen like it have supported all the file format which we have used in our project. So we'll see that how the Spark Read API or DataFrame Read API works. So in the screen, you can see the template for reading the CSV file. So I'm taking an example of CSV file because you can do multiple manipulation. You can apply multiple option into it. The Parquet format itself has the schema with it, schema information, and JSON, the info schema will not work because by default it is been applied on the JSON format. So I have taken the example of CSV file. So you can see that this is Spark. This is the Spark context or Spark session which you would have created. So I'm using the read method, and then format I am giving the CSV format. In the JSON, you have to give JSON format. I'm giving the option header equal to true. That means the first line of the schema. For example, I'll show you. So if I see any file, this is the custom file which I've created. So you can see the first line is the schema name, the structure of the file. So this will, what do you call, ignore this file. So when I write it here, header equal to true, that means it will ignore the file. Now we have an option, another for giving the path. What is the input path of the file? Then I'll come to this mode. Before that, schema, if you want to give the schema from outside, from external source, or you want to create a schema programmatically and you want to make the CSV format understand that this is the schema which will be applied, we will see with an example. So that we can give by the schema, and this is the schema name. The other thing is infer schema is equal to true. So if you want, like, the Spark read method should understand, this DataFrame API should understand by reading the data into the from the file, getting the schema, like which kind of what do you call, the file is or the data type is. For example, I'll show you, like, this is a string Santosh Saurav, this 38 in the integer. By looking into the sample of data and creating a data type, so that can be done with the infer schema. Okay, now we'll look into the mode fail. So this mode, we have multiple mode like fail fast. So there are few mode available for this: permissive, then we have fail fast, which is written there, then we have drop mail form. Okay, so we have three options you can give in this option mode. So the first is permissive. Permissive means if you have any corrupt record. So if you have any corrupt record in your data set, so it will make all the values of the column as null, and it will create a new column with a name underscore corrupt underscore column, or an underscore corrupt underscore record by this name. And in that column, the actual the corrupted record value will be kept. So the your job will not fail, but your the processing will not happen for that corrupt record. In fail fast, if ever there is a corrupt record, your full program, your full application will be stopped. In drop malformed, what happens in this, the record is dropped. For example, in 100 records, 2 records are corrupted, so 2 records will be skipped and it will be dropped. So you cannot, you will be not able to like find out by what reason that particular record has been dropped. In permissive, there is an option, like you can understand that what is the reason that the most of the all the columns of that particular record, corrupted record, is null, because you have the actual record in a new column which is which whose name is underscore corrupt underscore record. So these are the three modes available while reading the CSV file, or in fact any other files. So I'll just show this in a practical mode. So here what I'm using a file people hundreds of CSV. I got it from the from Google, a sample CSV file which has around 100 records into it. Let me see. Yes, we have 100 records. And now what I'm going to do, okay, just forget about this struct type. This will see now. So what I'm going to do, just I'll read this CSV file. So I think I have here, yes. So what I'm going to do, this is the Spark session which I have built. Format is CSV, header is equal to true, because in this one I have the schema name, that is a header. And then what I'm going to do, dot path, this is the path, and infer schema is equal to true. So if you don't give the infer schema, then also it will try to get the data type. So what I'm going to do in this case, I'm going to comment this line and then see how it will work. So what I will do, so, and also I also printed the schema. So I'll run this. Let me save it. I'll run this. So you can see this, the column name has been taken from the column which it is defined here. And then we have this data. You can see date is also there. So if you see here, everything like for index, they have taken it as a string. It should be integer, so that we can define. Then it has taken by default everything as a string because we have not done the infer schema. So now if now this time I'm going to do the, like for example, you can take this also, date of birth they have taken as a string. It should be date type. So what I'm going to do, I'm just trying to, I'll now try to include infer schema into it, and let's see how the data types behave here. Okay. We should align it properly, but fine, it will work because logically, syntaxically it is correct. So I'll run this now. So in this case, I have added the infer schema. So this time I assume that data type should be correct. Now you see date data type is date. Okay. Index is integer because it is inferring the schema. You can see by seeing the number of values in the record, it understands that which data type is there. So if index in some of the records, if I put some character value, it will take it as a string. So you can see date is there, date, index is integer, string, user ID is a string, first name is a string. Okay. So but in this infer schema is, it will hit the optimization of your Spark application because it will read the sample of the record. So you don't, like if you have a very large number of records, you don't want the infer schema to be added in your application, because while reading the file by for inferring the schema, it will read a lot of data while reading the file to understand the data type, and that will overall what you call will hit the performance of your Spark application. So in that case, what we do, we create our custom schema and then we tell the CSV like this is my custom schema. So how we do that? So we have a new struct type. So before that, I want to show you like Spark has its own data type, which is similar to what we write in Python, Java, or Scala. So if you go to this file, somewhere I had opened. Okay, so in the Spark documentation, you can see this. So I have opened for Python. You can open for Java. You can open for anything. Scala. Okay. So you see the data type like integer type. So for integer in Spark, you have to write integer type, and in Python it is int. So for example, in string, str is in Python string type, and in Spark we write string type. Similarly, if you see a more interesting one, for example, struct type. So the data structure which we use Python for Python in for list and tuple, that is struct type. Okay. So now map type is dictionary, dict type in what you call in Python. In Python, list tuple or an array is an array type. Date time date. This is for Python. Here we call it a date type. So now the question is why we have a separate data type for the Spark. Because when you write in any languages in Spark, for example, PySpark, Scala, or with the help of Java, you are writing a high-level programming language. But behind the scene, when the program gets compiled into the Spark framework, it gets converted into low-level language. It gets converted into RDD, and to make that conversion, what you call consistent, to make that conversion more meaningful and in line with the logic which you have written, Spark should follow a particular data type, and that should be same across all the languages. So if you go to Scala, the Spark data type will be same, but that will correspond to the Scala data type. Okay. So, and this is the reason why Spark has its own data type. Now we'll come back to this one. So for creating the schema, so before that, I'll just show you the data. So I have a data, two records. In fact, there's a three record. The first is the schema name and two data records. And now I'm going to this program. So I'm creating a struct type, which is kind of a list in this. And in struct field means column name. Struct type is the row. So in struct field, I'm giving name, age, address, and date of joining. So you can see here name, age, address, and date of join. The name should not be same. because just I'm creating a new schema. So your program will take this name rather than will it so your program will take this name instead of the name which you have given in the header. Okay. So here you can define the data type, like string data type is this, integer data type is this, address is string type, and date of join is date type. Because see, I'm not writing str, I'm writing the Spark data type, which is string type. Now this will make the thing more easy, because in the infer schema, it has to read the data to understand the data type. But in struct type, you have made the program understand this is a string type. Now, for example, while your data have what you call, if you have defined here, for example, age as integer type, yes, and in your corrupt data have age of some age by mistake is a string type. You have written ABC something in the age column, so that is a corrupt record, right? Because the age should be integer type, and we have defined in the schema, external schema. So that case, the Spark will behave as we give the mode. Now we have learned about the mode somewhere. We have seen a different kind of mode. This one I'm talking about, this mode. So how you have applied this mode, and accordingly your Spark will behave if the record is corrupted, if your record expects in your structure expect integer type and it has a string type. So in that case, your Spark will either end it, or Spark will skip that record, depends on which mode you have chosen, or which mode you have written in the Spark read CSV method or CSV API. Now I have created a struct type whose name is new schema. So I'm just reading the CSV file. This file I'm going to read two records. So I have given here dot schema, and this schema name I have given, right? And date format, I have given option date format, means you can define the date format. So here in my case it is YYYYMMDD. Okay. So that format I am defining it here. If you have a different date format, you can go to the documentation and each have their own keyword, a simple keyword how we use, because date format in Spark uses the same simply date format of the Java, right? So I'm just loading this file schema demo, and then I will print the schema also. So just a second, I'll just run this one. So now we'll run this code. Okay. So I printed the schema also. You can see the data is there, and the date, see the schema. You can see the date format, all the format which I have applied in the external schema, that has been done. So if you have a large volume of data, this method will work very fast compared to the infer schema. And in generally in the production, no one goes by the infer schema, because infer schema many times can be wrong depending on the volume of data. So it does the sampling of the data. So if the sample does not have the all kind of data in that particular column, then your answer will be wrong. So this is all about reading the CSV file. So we have another thing called writing the data into the sink. So we'll see the detail. So we have another thing of writing the data into the sink as something, some database or external source, how we have read the data. So writing also have multiple options, multiple ways. And in writing, we can also look into more optimized way, like increasing or decreasing the partition by key, or just we can restrict the number of records in a file. You can restrict the number of file itself. So everything can be done while writing the file, and more of the optimization thing can be performed. Like while reading, one of the optimization question can come from the infer schema. The other thing is the mode permissive fail fast. That mode question will come. And while writing, the multiple question on the optimization, Spark optimization types comes in the interview. So we'll see that in the next video. If you have any doubt in this particular video, you can post your question in the comment, or you can directly write a mail to me. You can get my email ID from the channel description. तब तक के लिए अपना ख्याल रखिए, टेक केयर एंड हैप्पी लर्निंग।